Trying to keep up with everything these days. It really does feel like drinking from a fire hose. Information overload everywhere you look. So that's kind of what we aim to do here. Cut through all that noise, we pick one topic, dive deep into a bunch of different sources, and try to give you those key insights efficiently.
Exactly. Getting right to the heart of it without getting bogged down. And today, we're tackling something that's kind of a big deal in modern application deployment, Kubernetes. Specifically, figuring out when this powerful tool is the way to go, and even more importantly, I'd say, when it might just be way too much, when it's overkill.
Yeah, exactly. Unnecessary complexity. So we've been looking at a bunch of different articles and analyses, all focused on Kubernetes deployments. And our mission here is pretty straightforward, to help you, the listener, figure out the crucial things to consider if you're thinking about using Kubernetes. When does it really shine? And when might you be better off with a simpler approach? Ultimately, save yourself some time, resources, and probably a few headaches along the way. So Kubernetes, let's break it down. What's the core concept here for folks who might be newer to this whole thing?
Well, Kubernetes, or K8s as it's often called, is basically an open source platform. It's all about automating the way you deploy, scale, and manage applications that are running in containers. Think of it like a super smart traffic controller for your containerized apps. But instead of just managing them on one computer, it manages them across a whole cluster of machines. Now, this whole thing started at Google. They had their own internal system called Borg, and Kubernetes was inspired by that. And it's become absolutely essential for modernizing applications, using things like containers, cloud-native approaches, and microservices.
Okay, so managing these containerized apps across a bunch of machines, what's the basic structure that makes all that happen?
At the heart of it, Kubernetes has two main parts. You've got the control plane and the worker nodes. Now, the control plane, that's like the brains of the operation. That's where the decisions are made. It includes things like the API server, which is how you interact with the whole Kubernetes system. Then there's etc., which is like a secure storage vault for all the configurations of your cluster. You've got the scheduler, which figures out where your application should actually run on those machines. And the controller manager, which basically keeps an eye on different processes, making sure the whole cluster runs the way it's supposed to.
Right. And then those worker nodes are the actual physical machines.
Exactly. The worker nodes are the workhorses. They're the machines where those application containers are actually running. And each worker node has a few key components. There's kubelet, which makes sure your containers are running as they're told. Then there's kubeproxy, which handles all the network traffic going to your containers. And lastly, you need a container runtime, something like Docker or Containerd, which is what actually runs the containers themselves.
So this whole setup takes care of a lot of those operational tasks automatically. What are the big advantages that have made Kubernetes so popular?
Oh, there are quite a few. First off, you've got scalability. Kubernetes lets your applications scale up or down dynamically. It can add or remove containers automatically, depending on how much demand there is. And that elasticity, that ability to adapt, is crucial for handling, those unpredictable spikes in user traffic.
Yeah.
Then there's orchestration. So Kubernetes automates the whole process of managing those containers across all those different computers. It handles the deployment, performs updates smoothly with minimal downtime, and it can even roll back to previous versions if something goes wrong. And then there's resilience. Kubernetes is designed to be self-healing. It's constantly checking the health of your applications and will automatically restart anything that crashes. And if an entire server goes down, it can even reschedule those applications to healthy servers. No problem.
Yeah, that self-healing thing, that sounds especially valuable. What else does it bring to the table?
So beyond those core benefits, you also get portability. Applications running on Kubernetes can run pretty much anywhere. Your own servers, public clouds, hybrid setups, you name it. It gives you a lot of flexibility and prevents you from getting locked into a specific vendor. And then there's a lot of built-in automation for all those routine operational tasks. Frees up your team to focus on more important things, and it improves your resource efficiency by smartly distributing those containers across your infrastructure, so you're not wasting anything. For development teams, Kubernetes can really boost DevOps efficiency. It streamlines workflows, helps you get releases out faster. It also provides infrastructure abstraction, so developers can spend more time coding and less time worrying about the nitty-gritty of the environment. And on top of all that, you get built-in service discovery and load balancing. This makes it super easy for different parts of your application to talk to each other and distribute all that incoming traffic efficiently.
Okay, so we're talking a whole lot of benefits here. But some of the stuff we've been reading points out that, these advantages really come into play for certain types of projects.
Right. Right. And that's a really important point. You see, Kubernetes is really built for managing distributed systems and those workloads that are constantly changing. Think about it. Automatic horizontal scaling, sophisticated service discovery, that super robust self-healing. These features were all designed to handle the complexities of running lots of interconnected services that need to adapt on the fly to different demands. So the first key takeaway here is to really step back and ask, does your project actually have those characteristics? A distributed system with dynamic resource needs. If your workload is pretty stable and self-contained, some of Kubernetes power might just go to waste.
Right. It's like using a sledgehammer to crack a nut.
Yeah.
So let's dig into those ideal scenarios a bit more. When does Kubernetes really excel? What kind of projects are we talking about?
Well, a perfect example is a microservices architecture. If your application is broken down into a bunch of smaller independent services, Kubernetes is a great match. It can handle managing all those containers, automate their deployment, and make sure they can all communicate with each other seamlessly. Each microservice can be scaled and managed independently, giving you a lot of flexibility and making the whole system more resilient.
That makes a lot of sense for applications that are split up into those smaller pieces. What about applications that see those big swings in traffic?
Exactly. For high-traffic applications, Kubernetes auto-scaling is a game changer. It can automatically spin up more instances of your application when things get busy and scale them back down when traffic subsides. That way, you've got enough horsepower during peak times without overspending on resources when you don't need them.
And for those really intricate deployments, the ones with tons of interconnected parts.
Right. If you've got complex deployments that need very specific configurations, advanced communication protocols like REST APIs or gRPC, and fancy deployment patterns like blue-green or canary deployments, Kubernetes has the tools and the flexibility to manage all of that safely and efficiently.
We've also seen cloud-native applications mentioned quite a bit. How does Kubernetes fit in there?
Oh, it's a natural fit. Kubernetes is built for cloud-native applications. It makes it a lot easier to deploy and manage them across different cloud environments. Public cloud, private cloud, hybrid cloud. It doesn't really matter. And its portability helps you avoid getting locked into a single cloud provider.
Makes sense. And what about streamlining the development process? Does Kubernetes help with that?
Definitely. CI/CD pipelines can really benefit from Kubernetes. It integrates seamlessly with those continuous integration and continuous delivery tools, so you can automate the entire process of building, testing, and deploying your applications. That translates to faster and more reliable releases.
It's interesting. Some of the material we looked at also mentions some more specialized use cases for Kubernetes.
Yeah, that's right. For things like AI, ML, and big data workloads, which often need a ton of computing power and have complex scheduling requirements, Kubernetes can be really powerful. It can help manage all of that, including things like taking advantage of specialized hardware and scaling your processing power up and down as needed. And then, believe it or not, it can even be used to build internal serverless or PaaS platforms. That way, developers within your organization can quickly deploy their applications without needing to become Kubernetes experts themselves.
So we're seeing Kubernetes as a powerful tool for all these demanding situations.
Yeah.
Any real-world examples of this in action? Companies that are using it effectively?
Oh, absolutely. Look at Netflix. They run their entire streaming service, which is massive, across multiple cloud providers using Kubernetes. They're handling millions of requests every second and scaling their infrastructure dynamically based on how many people are watching. Then you've got Spotify, who use Kubernetes to manage thousands of microservices for the music streaming platform. It allows them to do continuous delivery and automate all those complex workflows. Even Shopify, the e-commerce giant, relies on Kubernetes to handle those crazy traffic spikes during big shopping events and to keep their infrastructure modernization efforts moving forward. And in more specialized areas like high-performance computing, HPC, which is used in government, science, finance, engineering, Kubernetes is helping manage those super-intensive computing tasks across hybrid and multi-cloud environments. And in the world of AI and ML development, it's being used to automate the management and scaling of the entire machine learning lifecycle, from training models to deploying them in production.
Oh, so these are some pretty big players, all dealing with massive scale and complexity, which brings us to our second key insight, right?
Exactly. These success stories really highlight Kubernetes' strength in managing, well, complexity and scale. So the question for you, dear listener, is, does your project really need that level of sophisticated orchestration? Is it the right tool for the job?
Yeah, that's a really important question to ask up front. Now, let's flip things around a bit. When might Kubernetes actually be too much? When is it overkill?
There are definitely times when Kubernetes can add unnecessary complexity. For simple applications, the ones with minimal backend logic, like a basic static website or a simple front-end application, Kubernetes might be overkill. The dynamic orchestration and scaling capabilities, they might not be necessary. And similarly, for lightweight applications, maybe something that just runs in a single container with predictable resource needs, simpler tools can probably get the job done without all the extra overhead of Kubernetes.
So what about those older legacy applications, the ones that haven't been modernized yet?
That's where things get interesting. For monolithic architectures, just taking them as they are, packaging them up in containers, and deploying them on Kubernetes without actually breaking them down into smaller, independent services might not give you the full benefits of Kubernetes. You might not get the independent scaling and fault isolation that you would with a microservices approach. Now, there might be reasons to do it, maybe for some basic cost optimization or to standardize deployment, but it's often not the best fit for Kubernetes. Remember, Kubernetes is really designed for distributed systems.
So it's not just about the application itself. The size and expertise of the team managing it also matters.
Absolutely.
Okay.
For smaller teams with limited resources, the learning curve and the operational overhead that comes with Kubernetes, those can be real challenges. You need specialized skills to manage it effectively. And if your team ends up spending most of their time managing Kubernetes instead of building your application, well, the benefits you were hoping for might be outweighed by all that extra effort. And then there's the potential cost of hiring people with those specialized Kubernetes skills.
And speaking of cost, that's another big factor to consider, isn't it?
Definitely. Running Kubernetes can get expensive, especially if you're using a cloud provider. They'll often charge you for the control plane, the compute resources or nodes that your containers run on, load balancers, and storage. If you're not really using all of Kubernetes' capabilities, or if your deployment is relatively small, those costs might actually be higher than what you'd pay for a simpler solution. To really make Kubernetes cost effective, you usually need to be operating at a pretty large scale.
So if Kubernetes isn't always the right answer, what are some of those simpler alternatives that people should be looking at?
There are some good options out there, depending on your needs. Docker Compose is a great tool for defining and running multi-container Docker applications on a single server. It's pretty easy to learn and works well for local development and testing. However, it doesn't have all the advanced orchestration features of Kubernetes for managing things across multiple hosts. Then you've got Platform as a Service, PaaS offerings like Heroku, AWS Elastic Beanstalk, or Google Cloud Functions. These provide a higher level of abstraction. They make deployment simpler and let you focus more on writing code. And they often come with automatic scaling built in. These are a good choice for small to medium-sized web applications.
What about running containers without having to manage the servers at all? Is that an option?
Yeah, for that, you've got Containers as a Service, PaaS platforms like AWS Fargate, Google Cloud Run, and Azure Container Instances. These let you run containers without worrying about the underlying infrastructure. They often have pay-as-you-go pricing and automatic scaling, which makes them a good fit for applications with workloads that fluctuate a lot. And then there's simpler orchestration tools like Nomad from HashiCorp. Nomad's a bit more straightforward than Kubernetes, but it can manage both containerized and non-containerized applications. And then there's Docker Swarm. Swarm's generally easier to set up than Kubernetes, especially if you're already familiar with Docker, and it can be a good option for smaller deployments.
So it sounds like there's a whole spectrum of options out there. How can people decide which one is right for them?
Yeah, it can be a bit overwhelming. But it helps to think about a few key comparison points. Things like the complexity involved, the scalability each option offers, their orchestration capabilities, what kinds of use cases they're best suited for, how much infrastructure management you have to do, and, of course, the costs. For instance, Docker Compose, it's pretty simple to use and great for local development, but its scalability and orchestration features are limited. PaaS solutions, they offer low complexity and often automatic scaling, so they're ideal for those simpler web apps. And the provider takes care of all the infrastructure management for you. CaaS also has low complexity with managed infrastructure and automatic scaling, which makes it good for those variable workloads. Nomad's a little more complex, but it offers excellent scalability and can handle a wider range of applications. And then Docker Swarm sits somewhere in between, with low to medium complexity and decent scalability for smaller deployments.
So the key takeaway here is to really do your homework and understand your specific project needs.
Exactly. Think about how complex your application is, how much scalability you need, what your team's expertise is like, and how much budget you have. Once you've got a clear picture of those factors, you can choose the deployment strategy that makes the most sense for your situation.
All right, let's circle back to the human element for a minute. We touched on this earlier, but let's dive a bit deeper into the learning curve associated with Kubernetes. How steep is it, really?
Well, there's definitely a learning curve with Kubernetes, and it can be pretty steep. To really become proficient, you need a solid foundation in a few key areas. You need to understand containerization itself, so you'll want to be familiar with Docker or Podman. You also need a grasp of basic networking concepts, things like how IP addresses are organized into networks, often using CIDR notation, and a general understanding of how networks communicate. And being comfortable with Linux is definitely helpful since Kubernetes often runs on Linux-based systems.
And then there's all the specific Kubernetes stuff to learn on top of that.
Right. You need to get comfortable writing those Kubernetes configuration files in YAML. Understanding the core architecture of Kubernetes, the control plane and the worker nodes, and those fundamental Kubernetes objects like pods, deployments, and services is essential. And then there's kubectl, the command line tool you'll use all the time to interact with your Kubernetes cluster. That takes some getting used to.
So that's a lot to wrap your head around. It
Heh.
sounds like it doesn't stop there.
No, not really. As you get more comfortable, you'll probably need to learn about more advanced topics, things like ingress, which is how you manage external access to your applications, or Helm and Customize, which are tools for packaging and managing Kubernetes applications. And then there are operators, which let you extend Kubernetes to manage more complex applications. And, a lot of the resources we looked at actually highlighted that understanding and correctly defining all those Kubernetes objects in YAML, that's often one of the biggest challenges for people who are new to Kubernetes.
It's not exactly a pick up and play kind of technology then. So how can this impact a team's day-to-day work? What kind of adjustments should teams be prepared for?
Well, teams need to be prepared to invest a decent amount of time and effort upfront to train and get comfortable with Kubernetes. That might mean a temporary dip in productivity, and it could lead to longer release cycles as teams adapt their workflows. Developers who aren't used to thinking about infrastructure might find the whole Kubernetes development workflow pretty different from what they're used to. It's quite possible that they might end up spending more time dealing with configurations and troubleshooting cluster issues than actually writing application code.
So it's not just a technical challenge, but a potential cultural shift for some teams as well. So how can teams effectively bridge that skills gap and get up to speed with Kubernetes?
There are a few good approaches. Investing in solid training programs for your team is key. That's how you build up that in-house expertise. Hiring experienced Kubernetes professionals is another option, but as we mentioned earlier, that can get expensive. You can also look at leveraging managed Kubernetes services offered by cloud providers that can take a lot of the operational burden off your team. And then there are higher level abstraction tools that can simplify the way developers interact with Kubernetes. Those can help bridge the gap and make the transition a little smoother.
All of that really reinforces the idea that adopting Kubernetes is a big investment, not just in terms of infrastructure, but also in terms of the time and effort needed to upskill your team.
Absolutely. And that leads us to our third key takeaway. The steep learning curve and the amount of knowledge required to really master Kubernetes, that can be a major barrier, especially if your team doesn't have any prior experience with container orchestration. So the big question you need to ask yourselves is, are you, as a team, ready to make that commitment to learning and upskilling?
That's a crucial question to ask before diving headfirst into Kubernetes. Okay, so let's talk about some red flags. What are some specific metrics or indicators that might suggest Kubernetes is actually overkill for a particular project? What should people be watching out for?
There are a few key things to keep an eye on. First, look at your resource utilization metrics. If you're consistently seeing very low CPU and memory utilization across your cluster, it could be a sign that you've over-provisioned your resources. Maybe a less resource-intensive setup would be perfectly fine for your needs. Likewise, if your network traffic is low for applications that aren't really network heavy, it might suggest that you're not actually making the most of Kubernetes' advanced networking capabilities.
What about how often those core Kubernetes management features are being used? Can that tell us anything?
Absolutely. If you hardly ever see those orchestration features in action, that could be a red flag. For instance, if your horizontal pod autoscaling isn't really triggering because your application load is pretty consistent, or if those self-healing mechanisms rarely kick in because your application is super stable, you might not actually need that level of dynamic management that Kubernetes provides. And if you're not using advanced deployment strategies like blue-green or canary releases, it could be a sign that your deployment needs are simpler than what Kubernetes is designed to handle.
So it's not just about the resources themselves, but also how those core Kubernetes features are being utilized. And what about the balance of effort between managing the platform and actually developing the application?
Yeah, that's a huge one. If a small team finds themselves spending most of their time on operational overhead, things like managing the Kubernetes cluster and troubleshooting infrastructure problems, and very little time actually building and releasing new features, that's a strong indication that Kubernetes might be adding more complexity than it's worth, given what your application actually needs. It's about finding that right balance.
Makes sense. And finally, let's come back to the cost issue. Are there any specific cost-related red flags that people should be aware of?
Definitely. If you notice that your costs are significantly higher compared to other alternatives and you're not seeing a clear benefit in terms of scalability or reliability, that's a big warning sign. Basically, if moving to Kubernetes has actually increased your operational cost for a relatively straightforward application, it's time to reevaluate your deployment strategy.
So being proactive and monitoring all these factors, it sounds like that can give teams a really good sense of whether Kubernetes is truly adding value or just creating unnecessary work and expense.
Exactly. And that brings us to our fourth and final key takeaway. By keeping a close eye on these metrics and patterns, you can get a much better sense of whether Kubernetes is really giving you a good return on your investment or if it's becoming an unnecessary burden. We encourage all our listeners to think about these indicators and how they apply to their own specific context.
So to wrap things up, the decision of whether or not to adopt Kubernetes, it's not a simple yes or no. There's a lot to consider.
Absolutely. Kubernetes is a powerful and flexible platform, no doubt about it. It's incredibly valuable for managing complex, scalable, distributed applications, but it's not a one-size-fits-all solution. It's not the right tool for every project.
The key is to really make sure your chosen deployment technology matches the specific requirements of your project, the skills and resources your team has, and your budget.
Exactly. Don't just jump on the Kubernetes bandwagon because it seems like the cool, modern thing to do. Carefully weigh the benefits against the complexities. And don't be afraid to consider those simpler alternatives if they seem like a better fit for what you're trying to achieve. So as you consider all those different deployment options out there, from just running single container to orchestrating a huge interconnected system, what are those fundamental characteristics of your next project that will really dictate how much complexity you actually need in your deployment? That's a really important question to ask yourself, even before you start thinking about setting up that Kubernetes cluster.